So help me understand, what is silicon 28? And I know that you play a special role in developing this isotope, and we'll unpack what isotopes are. But what application might silicon 28 have for the semiconductor industry, and why are firms reaching out to you to learn more about it?
So silicon has three isotopes, one with a mass of 28, another with a mass of 29, and another with a mass of 30. But the 29 isotope doesn't conduct. It actually is a negative conductor. So you think about 28 facing this way and 29 facing that way, the current flow this way, 29 blocks the current flowing. So we can remove that 29 isotope and enrich it really highly enriched in the 28 isotopes, talking about 99.995% enriched in the 28 isotope. Your conductivity goes up thousands of fold, and your heat transfer capability increases multiple folds as well. And there's a lot of good data emerging showing that. We recognized very early that in order to enable quantum computing, one is going to require highly enriched silicon 28. So we initially started thinking silicon 28 would be useful for quantum computing. But obviously, as you mentioned earlier, there's huge demand for high processing capabilities in these data centers and these new microchips and semiconductors. There's a belief that if people use silicon 28, the performance of the semiconductor will increase thousands of fold. And that will obviously bring down the size of the semiconductor, the amount of heat you generate, the amount of power it draws, all those associated benefits with it. So we've got a lot of interest from a number of semiconductor companies, a number of industrial gas companies who are desperate to get this highly enriched silicon 28. And that desperation wasn't there 12 months ago. 12 months ago, we were talking to most of the semiconductor companies about enriched silicon 28, and there was an interest in it. But I think that interest suddenly became more of an urgent need for it as we got into first quarter of this year.
So silicon 29, is that the primary silicon isotope used in semiconductors today?
No, so right now, a semiconductor is normal silicon, so it's going to be 92% of the 28 isotope, about 3% of the 29, and 4% of the 20 of the 30. If we can strip out that 3%, then it's much faster.
Oh, I see. So it's really purifying the silicon that's used in the semiconductor application to improve the conductivity as well as the energy efficiency, the heat transfer. That's the basic idea. And improving that purity drives this efficiency.